2. So scatter expander is like, so it expands, it anyway transforms scatter instruction to the like while like instruction that using while loop, because if you remember the previous explanation, it actually iterates the number of like outer dimensions to fill the row or column, depending on, based on the update windows and indices. So yeah, if you have a operand indices updates, the for loop will be iterated based on these two properties, and it fills the content here. So if you see this path in a high view, we first need to perform characterization on indices of updates, and then we need to construct a while loop based on the number of iteration space from these tensors. So this is actually it consists of these two steps. And for characterizations, because we have two properties, so we need to do a characterizations on both sides. First, scatter indices. So it actually also have two steps also for updates too. So first, we need to put the indices to the rightmost rank. So there will be like, could be a batch, or the number of dates could be out of order, but after characterizations, the code length will be the rightmost side. And then if you already, the code, in more typical cases, the code rank is already in the right side. So in that case, it's also no or. Only if the code rank inside the or left side, then it will moved. Otherwise, we didn't do anything. But if it is in the middle, then we need to add the instruction of transpose in the middle. And then if we have this shape, the rest thing we need to do is like, so basically this is the iteration space. So it doesn't have to maintain as a many rank dimension. So it collapses and then makes it to 6 by 2, and it will iterate 6 times. And also, it's also doing the same thing on a updates tensor too, but the function names are different, but what it does is same, exactly same. In worst case, you put a transpose and reshape, but if it's a happy case, you already have a canonicalized update or indices, and your dimension is already collapsed, that you don't have to do anything.
What do you mean by dates is tensor that you want to write, right?
Yes. Indice is the where you put. So I just prepared some big diagram to what does this loop body actually means. So because we have two tensors, where to put and what to put. So, and you need to read specific part from entire tensors, right? So you need to have a dynamic slice for that. And also, with only this, we don't know which index in the operand side. So we need using a scatter index to operand dims, using this property, using this map. We know the real index of the operands, and these operands will be updated for the loop count. So at every current index, you need to retrieve operand current again, and using these operand indices and using the operand through the dynamic slices, you get the operand slices, and then using update slices, you will fill your override, or you will accumulate whatever you want to do. You do the update the parallel update tensor again, and then you will repeat this up until like, or the iteration space times. And scatter expander also have 3 modes. One is eliminate all scatters. That is the mode that we are running on the CPU. What it does is like it removes or it converts all the scatter operation into while loop. And there are second mode, which is eliminate simple scatters. And this is like most case, if you just override your operand just one time, then it's going to be a simple mode. In that case, without like converting into while loop, which incurs for loop, it changes it to dynamic update slice operation because it doesn't have a while kind of. You don't have to create a loop. And the last mode is eliminate indeterministic scatters. And what I mean by deterministic is like this. The case is not falling to this. So for example, every indices doesn't collide it together, that is deterministic. If the indices can be collided, then depending on your operation could be depending on the order of the group, it could be, if you run in parallel, they could give us like different order, different output. And also if your update computation is not associated, add, min, or max, regardless of your order of execution, it always give you the same output. But for example, like sub or the operation that is not associated, that you, depending on the order of execution, you can get different output. And also, if you just run this just one time, then you always get a same result, right? So the principle is like indices can be duplicated, and your operation doesn't support associated property, then it could be an indeterministic.
One question. So scatter can be parallel operation, so it's not in. So when you said it's a while loop, I thought it's like single-threaded.
Yeah, I thought so, but it seems that it could be running parallel. Otherwise, if you run like serial, you don't have, there's no, you always deterministic, right? But what I mean, because it says that scatter can be indeterministic, it means that this scatter operation, the generated while loop can be run in parallel.
Does scatter expander also count the multi-machine context as well? Or is that only for like a single machine?
I guess single machine.
Then,
Because SPMD already split. Because I think SPMD will be run before this. That's what I assume. So
that like scatter feels like scatter because that its definition is a scatter to like multi where's it? But if that is like for the single machine, then what's the difference between like a scatter and scatter expander?
Scatter expander is actually on a pass,
Uh-huh.
which will expand the scatter into a while loop. So it eliminates scatter operations and converts it into a while loop. So it's
The purpose is eliminate the scatter itself.
So CPU backend, even like the CPU backend will be the most powerful backend. Even CPU backend doesn't support scatter instruction directly. So it removes scatter and it changes it to more simpler version of operations. So yeah, in this case, in this example, the subtract is now associated, so it's marked as indeterministic, But if you run in like serial, it doesn't have a problem. It always give you 70. Or also in this, yeah, if I do myself, 100 minus 10 or 100 minus 20, also 70. But I think it's so strict that mark it as the indeterministic. In this example, even though it is marked as indeterministic, even though in this simple setting, so if you run like first index first to second index later, or second index first index later, it gives you, in this example, it gives correct the same result though. But the code itself, it gives you like it treated as indeterministic thing.
Oh, what this thing was 100 first? Mm. Mm. How would it be in the? I mean,
while이 deterministic하게 해주는 거구나. 제가 잘못 설명했다. while이 deterministic하게 해주나 보다.
if this is deterministic, then basically everything is deterministic, no?
I think there could be a example, but I can't find example for that could possibly give us indeterministic output.
I was thinking of like maybe I don't know.
돼요. 잠시 보고 올게요.
너무 봤어.
What? How could it be indeterministic?
Nice.
Okay.
여기 예제가 있는 것. So I think that could be in a complex setting. There will be some example that give, if you run this scatter, give me the kind of possible many output based on the operation order, but I couldn't find a example for that.
So it just checks if the update computation is associative or not, right?
Yes.
That's the only check.
Yes.
Hmm.
And it also checks this, and it only checks this too.
Mm. Hmm.
Also, I think this, so the reason why I mentioned like CPU backend is because like it also assumes that some certain hardware supports scatter instruction, some custom hardware. So it can interpret or it can run scatter instruction directly. In that case, like in some setting, give us like indeterministic output. But if you even in this hardware, if you turn this into while loop, it can give us deterministic output. That's what this mode is trying to do. But yeah, I couldn't find a good example to copy this. Okay. Thank you.
Thank you.